So the second topic of today is the dot product. Vectors have two ways, well, actually three ways of being multiplied. We have the scalar product that we saw before. We have something called a dot product, and there's something called a cross product. So the three kinds of products are the scalar product, the dot product, which we're about to see, and a cross product. We'll look at that on Wednesday. So the scalar product is a scalar times a vector. So this is a vector. We're going to see that the dot product is a scalar. And the cross product is the only product of a vector with a vector that has the result of a vector. And these are both really beautiful and helpful, useful. So the definition of the dot product, if U is U sub x, U sub y, and V is V sub x, V sub y, then the dot product is the product of the U sub x, V sub x, plus the product of U sub y, V sub y. And since all four of these quantities are scalars, their products are scalars, their sums are scalars, this whole thing is a scalar. So let's let U be 5, -1, and V be -3, 4. The dot product of U and V, well, that's 5 times -3 plus -1 times 4. So -19. And let's notice that the dot product is commutative. If I found this product as UV, VU, then I would have -3 times 5, 4 times -1. But regular multiplication is commutative, regular addition is commutative. So we're going to get the same value. And that's wonderful. If it wasn't the same, then we would have issues. Well, what about U dot U? Let's see, U is 5, -1, so that's 5 times 5 plus -1 times -1, 25 plus 1, 26. It's weird, but it's doable. The magnitude of U, let's see. The magnitude of U is U sub x squared plus U sub y squared. So let's see, be 5 squared plus -1 squared So the square root of 26. Oh, check it out. U dot U is the square root of 20 squared. So we could get the magnitude of U by finding U dot U and dividing by, oh, and taking the square root of it. Cool. So we can, just for fun, let's look at V. So V dot V well, V was -3, 4. So -3 times -3 plus 4 times 4. That's 9 plus 16 is 25. And the magnitude of V is -3 squared plus 4 squared, which we can see is the square root of 25, or 5. So the magnitude is the square root of the dot product, or the dot product is the square of the magnitude. There's some notation conventions that we have to get clear here. We have 3 terms that have to do with 90-degree angles, or pi/2 angles: orthogonal, perpendicular, and normal. 2 lines in a plane are perpendicular. So lines are perpendicular. 2 vectors that meet at a right angle are orthogonal. And a vector coming out of a plane is normal. So if we've got a plane and a vector coming out of it and the angle created is 90 degrees, then that vector is normal to the plane. 2 vectors that have an angle between them of 90 degrees are orthogonal, and lines are perpendicular. We want to see if U and V seem to be orthogonal. Let's find U dot V. So we have 4 times -3 plus 3 times 4. That's -12 plus 12 is 0. Well, that's very interesting. So we got a dot product of 0. And we're going to show this in a minute, but the cosine of the angle between 2 vectors is their dot product divided by their magnitudes, the product of their magnitudes. If the angle is, if this is 0, so cosine of 90 degrees or cosine of pi/2 is 0. So if this value is 0, then we say that they're orthogonal. And this quantity can only be 0 if U dot V is 0. So if the dot product is 0, we know that that means the cosine of the angle between them is 0, and that means that that angle was 90 degrees. So let's see. Let's let U be -3, -3, and V be -3, 3. And let's show that they are orthogonal by finding the dot product. So we've got U dot V is -3 times -3, -3 times 3. So yeah, 9 minus 9 is 0. And this is kind of boring because it's just the same numbers where one negation is missing. And this one is the same boreable thing. So let's do a different example. Let's let U equal 5, 2. Oh, I know. Let's figure out what one of the components of V needs to be so that they are orthogonal. So let's let V be 2, and let's just call this V sub y. And let's find V sub y so that U dot V is 0, so that U and V are orthogonal. So we've got U dot V is 5 times 2 plus 2 times V sub y. So that's 10 times 2 V sub y. And I want that to be 0 because I want to create another vector that is orthogonal with U. So let's move, this is a plus. Let's move 10 to the other side. We'll have 2 V sub y equals -10 and divide by 2. And we get that V sub y is -5. And I did this example to show you that the only kinds of vectors that are orthogonal are vectors where the numbers match and where one negation is different. So there's one sign different. So we could have had 5, -2, 2, 5, or we could have had 5, 2, -2, 5. We just have one sign different. And here we've got U is -4, 3. V is 4, 3. But you see that the X values and the Y values are the same. And with orthogonal vectors, they have to switch. So we already have an idea that we're not going to have orthogonal vectors here. U dot V is -16 plus 9. And that is -7. which is definitely not 0. To find the angle between them, we need to find both magnitudes. The magnitude of u, well, 3, 4, 5 triangles, but let's see. We'll have -4 squared plus 3 squared. That's 16 plus 9 is 5. The same with v. So to find the cosine of the angle between them, have the dot product divided by the magnitudes. And the dot product was -7. The magnitudes are 5 times 5. So we've got -7 over 25 for the cosine of the angle. Okay, so we've got 7 negative divided by 25. And I get that the angle is approximately 106.3 degrees. And let's sketch it and see if it looks right. So we have theta is approximately 106.3 degrees, which is just larger than 90. So let's see. I think this will work. So we've got u is -4, 3. And v is 4, 3. And if I was just trying to look at this by eye, I wouldn't be sure if that was 90 degrees or bigger than 90. And you can see we're only 16 degrees bigger. And of course, my graph is perfect. But the dot product tells us that they can't be orthogonal. And you notice something. If we switch these coordinates, so if v were 3, 4, then its magnitude is still 5. The square root of 3 plus the square root of, 3 squared plus 4 squared is still 25, and the square root is still 5. But now u dot v will be -4 times 3 plus 3 times 4 is -12 plus 12. And that is 0. And where does that switch move v? So let's call, what color can we, okay. I'm going to let this brown color be the new v, which will be at 3 4. And even on this drawing, I can see, yes, that is indeed a 90-degree angle. So in order for two vectors to be orthogonal, their coordinates need to be switched, and at least one sign needs to be different. Oh, here's a fun one. What if the numbers are not at all going to be the same? So what if u is negative 2x and v is 3, 4? Is there an x that will work? Well, we know that the dot product is negative 2 times 3 plus x times 4 is negative 6 plus 4x. And we want this to be 0. So let's add 6 to both sides and divide by 4. 6 over 4 is 3 over 2. So let's see. If u is negative 2 3/2. Hi, Sarah. And v is 3, 4. Oh, so if we have that same rule that the order of the numbers has to be switched, so 4, 3, but here we've got a 2 instead of a 4. So we're dividing by 2, 3 divided by 2. So we can say if u is u sub x, u sub y, then v will be orthogonal to u if the component of v is some scalar times u sub y, same scalar times u sub x. Let's see if that's right. Let's find u dot v. So we'll have c, oh, and one sign has to be different. So we've got c times u sub x, u sub y, plus negative c times u sub x, u sub y, and that does work. So one vector can be a scalar copy of the reverse of the other vector, and then as long as one sign, SIGN, is different, then that will be a dot product of 0 so that those two vectors are orthogonal. And what we're doing by multiplying by a scalar is we're stretching v or shrinking v, but we're keeping its same direction. I think we have time for one more example. So let's see. What can y be so that 6y and 4, negative 8 are orthogonal? So we have 6y 4, -8. And that's 6 times 4 plus -8y. And we want this to be 0. So 24 minus 8y equals 0. I'm going to move the 8y to the other side to keep everything positive. So I've got 24 is equal to 8y. If I divide by 8, I get that y is 3. And let's see how u being 6, 3 follows the rule we just talked about. So v is 4, -8. U is 6, 3. I wonder if I factor out a common factor, if that will help me see it. So I can see that there's a common factor of 3 here. And there's a common factor of 4 here, so 4. So we have 1, 2, 1, 1, -2 with 2 different scalars. So let's see, let's let u be cu sub x, cu sub y, and v be b u sub y, -b u sub x. And let's see if we really do get a 0 dot product if we have a scalar multiple and it's different. So we'll have c times b u sub x times u sub y. And again, c times b, but we're negative. U sub x times u sub y. And we do indeed get 0. So 2 vectors are orthogonal if they are scalar multiples of one another and the order is switched and one sign is different. And I think we're at time. Are there any questions before we stop?
Yes, I have one.
All right.
I will have one as well at the end of this recording.
Okay, go for it.
Yeah,
Ben.
so when you said that the Alex assignments weren't necessary, we just had to do the try thises.
Right.
Where can we see those to do them? Like, where will they be assigned?
So that's a great question. Let me share my screen. Let me pull up. Okay, I'm going to share my screen. Do y'all see this Safari window?
Yes, ma'am.
Okay, and I'm just going to look at assignments this way. So I'm putting these assignments as like polar coordinates, notes and practice, complex numbers, notes and prep.
So it's the notes and practice ones?
Yes, and so
okay.
The notes are there, the video is there, and then there's a place to upload a file.
All right.
So following with this question for the it's the other one. just complex numbers was in practice.
Uh-huh.
I noticed there was a I guess a mistake somewhere.
Oh, yay. Good. Okay.
It's so if you click on the notes for complex numbers download. Yeah. So there's a sign difference somewhere in the try this is. Yeah, so it's from the try this one where Z4 has a 3 plus 4i, and then the rest are negatives. Like the Z4 3 minus 4i. There's a sign difference.
Oh my goodness. Okay. Yes, so those all should be the same. So this needs to be 3 minus 4i because all the others are. Okay, I will fix that. Thank you, Sir Ralph.
No problem.
That's
Oh,
5
actually,
points.
I have a question for Sir Ralph. You emailed me wanting to get in contact.
Yes, yes.
Yeah. So yeah, I don't have a phone to text you on.
Oh,
So
no problem. No
yeah.
problem. That was fine. That was a long
Uh,
time ago, so I don't
yeah.
really need it as much.
All right.
Thanks again.
That's it. Yeah. All right. Bye. See you next week. Oh well. See
Thank
you on
you.
Wednesday.
Have a wonderful couple of days.
You too.
See you Wednesday.